Just learning platform. I hope all of you are really working very hard for your upcoming CSIR-NET as well as the GATE examinations. How are you all, everyone? How are you all doing? Am I audible and visible? Is there everything going fine? So today's class is going to be very important, because in the today's class we'll be discussing about the most important organic chemistry questions. As you know, the organic chemistry are the very important for your upcoming examinations, right? And our main plan is to complete the 500 important questions or MCQs. So we'll be starting one by one. In the previous classes, I have already completed the very important question, as you have seen. So from here we have started, right? So this was a question from the bottom reactions. Now the next reactions we have done from these examples. Next one, this radical reactions is there. Next one is this one. So you can get this particular part in the playlist named by me. Kripasindhu Karmakar, मेरे नाम से अगर सर्च करोगे तो you'll be getting that. So do not forget to like the video and subscribe to this channel. This channel will be very important for your preparation. Okay. So here you will be getting a lot of important videos which will be extremely helpful for your upcoming examinations. So good morning everyone. May I know your name? How many of the students are present right now? Like after that we have solved this question. This question is a very important. And I have told you the shortcut trick of this, like by looking into the molecules, how we'll be giving the correct answer. Okay. So perhaps this is one of the important examples in which the stereochemistry of the 6:5 membered ring is becoming the transfused. Normally, whenever you'll be getting the opportunity, I have already told you that you have to form the cis fused ring, right? But in this particular scenario, the transfused ring will be the major product. So most of the students will be doing the mistake in these questions. बहुत सारे students इसमें इस question में गलती करेंगे, okay? But you should not, because this question is a very important and the exceptional also, okay? So here this is an example for the hydroboration reactions and the carbonylation reaction. So you have to take care of both of the scenarios in all of this regard, right? So then after that we have given this type of questions, which was very important. And the next step, this one I have given as a homework, right? मैं homework दिया था इस पे आपको. We have given these reactions also. This reaction has also been completed. We have taught the Bailey-Silman reactions. Bailey-Silman reactions is also important for your upcoming examinations, right? And I have also told you the shortcut of this Bailey-Silman reaction. By how only looking into the particular molecules, you will be giving the correct answer, okay? I have discussed that also. Now this one is a very important formation of the jasmine, cis-jasmine formation. Cis-jasmine formation. This is usually asked in the examination hall. Exam में normal पूछा जाता है. Now in the today's class we'll be starting from the new topic or new questions. Let me see how many of you will be able to solve these questions. Okay, great. So let's start this question. Good morning everyone. So let's draw the next example. Nitrogen and CH2PH. This is the benzyl group, and this one is the CO2Me. As all of you know, CO2Me is an example for electron withdrawing group. So this is basically has been treated with the 175 degree centigrade temperature and the toluene solvent. Toluene solvent के साथ reactions कराएगा. So ultimately A intermediate you are getting. So whenever A intermediate is getting treated with the molecule like this, Me, C double bond oxygen, and here is a double bond. So after this part, you are having the OTBS. So I have to finally give the product B. So you have to find out the product B with the absolute stereochemistry. Stereochemistry is the most important case over here. So बताओ how you will be giving this correct answer of this question. What will be the answer? Do you have any idea about this question? So now let's try to solve this question. So for this question, nitrogen is having the lone pair of electron, so which is forming the double bond, and it will forming the negative charge in such a way that will be stabilized through the electron withdrawing group. Since you know electron withdrawing group can stabilize the negative charge through delocalization. Electron withdrawing group can stabilizes the negative charge through delocalization. Delocalizations के through negative charge stabilize होता है, right? Delocalizations. So negative charge forms adjacent to the electron withdrawing. So as I have already told you that negative charge adjacent to the electron withdrawing group is stable, and the same time positive charge on the electron donating group is also stable. So depending upon the scenarios, whether the negative charge has been given or the positive charge has been given, you have to take care of this. Okay, great. So in this case scenario, A intermediate will be forming as like this one, nitrogen, and here is the CO2Me, where this group will be having the negative charge. Now since nitrogen has donated the electron, so all of you know all of the time donation is a positive work. Donation is a positive work. So donation is a positive work. So in this case scenario, कौन donate कर रहा है? Nitrogen is donating, right? So nitrogen will be having the positive charge. Now which orientation is correct? देखो. Now let's take whole of the molecule as a R, so that it will be creating less, like it will be having less problem. Okay. Now there are the two possibilities of orientation is possible in this case scenario. देखो. First possibility of orientation is like this, in which this will be attacking like this, and the second orientations will be like this. Negative charge, positive charge. Now we are taking the another orientation, which is like this. So if you look into this particular things properly, then you will understand कौन सा charge stable होगा. देखो, this one is an example for the electron withdrawing group. So electron withdrawing group के adjacent में always delta negative charge stable is, right? So this one is a negative charge, this one is a positive charge. But in this case scenario, this will be negative, this will be positive. So here if you see the interactions, अगर interaction देखोगे तो क्या समझ में आएगा? In this case scenario, negative charge is actually interacting with the negative charge, and here positive charge is actually interacting with the positive charge. So that is not going to happen, right? Because ultimately the opposite charge will be ultimately forming the bond. So here negative charge will be attacking to these positions. This will be forming stabilization through the electron delocalizations. Now this negative charge will be attacking to this, and nitrogen's positive charge will be neutralized. Nitrogen का positive charge क्या हो जाएगा? Neutralized हो जाएगा. So here is the CH2PH, here is also the CH2PH. So finally the correct answer for this particular questions will be the group like this. क्या बनेगा finally? Let me take the another slide in which you have to keep the geometry of these molecules. So ultimately it is not important to show the stereochemistry of the CO2Me. Any one of the things that you could show, right? But in this case, showing the stereochemistry is also important, right? So COMe, and here is the group, right? So अब बताओ. So what is the stereochemistry of the both of the groups will be R and CO2Me. R and CO2Me group का दोनों का COMe का stereochemistry क्या होगा? So in this particular scenario, since this is an example of a E double bond, so ultimately it will be forming the anti product. So always remember, E will be giving the anti and Z will be giving the syn product. So if let's suppose you are reacting with the group which one is R1 and which one is R2, so they will be giving a molecule in such a way, क्या होगा? दोनों group opposite in nature होगा. One is R1, if one is above the plane, another should be below the plane. Okay. So this one we have to draw for the E alkene. This one we have to draw for the E alkene. Now if the two alkene, this is forming the Z alkene, This one is R1, this one is R2. So ultimately it will be forming the ZR. So this one is R1 and this one is R2. They are forming the bond like this, right? Is it clear, everyone? So finally, for these molecules, this will be leading to the R group, and the stereochemistry of the COMe will be below the. So finally, the correct answer of this question will be this one. Finally, the correct answer for this question will be this one. Is it clear? Now let's solve the next question. I'm giving a question and I'm giving you the 2-minute time so that you can solve this question and give me the answer. Okay, just mark this question as a very important, because all of the questions, whatever the questions I are discussing, all of the questions are very important. So I'm giving a particular group in such a way. Here is the OH, here is the methyl group, and CH2, here is the NHMe, and this is reacting with pyridine, and here is a CHO, camphor sulfonic acid. PHH remains the benzene, and the 8 degrees centigrade temperature. Okay, so finally what is the product will be formed? A kya banega, right? So find out the major product in the A. So take some time and give the correct answer. Take 2-minute time and solve these questions. Okay, all of you trying. देखो, whenever you'll be having a very bulky group and that will not be reacting into the reaction medium, so you'll be taking that particular molecule as AR. If this is aromatic molecules or like that, take the R group also. So normally in this scenario, because this is aromatic in nature, that's why we are taking the AR group. So this is basically can be abbreviated as the molecule of the ARCHO. So this can be written as the ARCHO. Aldehyde group is present, right? Now just try to understand everyone. Now in this particular molecule, we'll be writing down this group in such a way that these molecules will be looking like the 6-membered form, right? So one is the NH and one is the methyl group, right? and we will be putting this molecule of this group into like this. So ArCHO. Now camphor sulfonic acid is a source of the proton H positive. So at first the protonation will be taking place, so which enhances the electrophilicity of this carbon, right? इससे इस कार्बन का इलेक्ट्रोफिलिसिटी बढ़ाएगा. Now you know one of the nitrogen is having the lone pair of electron. Now here the attack is taking place and ultimately the elimination of the water takes place from the reactions conditions. So if you eliminate the water, will be directly forming the iminium ion over here, because here there is only one hydrogen. जब भी one hydrogen present होता है nitrogen के साथ, then in that particular scenario it will be forming the iminium ion. So here is the Ar group and nitrogen will be having the positive charge. देखो, nitrogen is having the capability to form the 3 bond. If you give more than 3 bond, then you have to assign the positive charge. If you give less than 3 hydrogen, less than 3 bonds, then you have to give the negative charge. So ultimately its 3 valency will be fulfilled. Its trivalency of this nitrogen has been fulfilled in all of the cases. Dekho. Now you are getting this particular part. Now what will be the next step? Next step is very easy. Will be the example for the 3,3 sigma tropic rearrangement. Why this is 3,3? The bond which is being broken, that is normally given as a 1 and 1. Then just try the adjacent groups, so 2 and 3. Now the new bond formation takes place between the 3 and the 3, and this is an example for the 3,3 sigma tropic rearrangement. This is an example for the 3,3 sigma tropic rearrangement. So finally what is the group will be forming? So finally there is a new bond formation takes place in between this and this. Here is aromatic molecule is there, nitrogen, and here is a double bond, and here is a methyl. Now बताओ what is the charge that nitrogen will get right now? अभी भी nitrogen को कौन सा charge मिलेगा बताओ? So nitrogen will still be having the positive charge, because ultimately its positive charge has not been neutralized, because this is an example for 3,3 sigma tropic reactions. That's why its positive charge has not been neutralized till now. Okay. So in the next क्या होगा? So that is the reason because of which ultimately oxygen lone pair of electron will be forming the double bond, and it will be attacking to these positions, and positive charge of the nitrogen will be neutralized. So finally how many membered ring will be forming? So 1, 2, 3, 4, 5. So there will be the formation of the 5 membered ring. And now what is the charge on nitrogen? अभी nitrogen के ऊपर there will be no charge. That means nitrogen is containing lone pair of electron. Okay, and here is the aryl group, and here is the COM group. But the positions are the very important scenarios. Okay, but the positions are the very important. So this one is 1, this one is 5, this one is 4, this one is 3, this one is 2. Is it clear? Very good, Vaishnavi. So all of you have completed. Okay, now let's do the another examples, right? इसके बाद और एक अलग अलग से एग्जांपल लेते हैं. चलो, good. Now let's see the next questions can be done by you or not. in the next questions. So in the next questions will be the question from the very important topic. As you all know that the organic chemistry is a very important for your upcoming examination in all of the cases, right? Sure. So now let's do the next part. Double one. There is a C3, A7, SiMe3. Then next, we are treating this molecule with the MCPBA, that is forming A. And now after this, we'll be forming the Me2CuLi. Gilmer reagent you are using diethylether and minus 78 degrees centigrade temperature. So this one is forming the B. Now next one is the osmium tetroxide you are forming. Osmium tetroxide, acid butanol acetone, and water. And with it, this one is the N-methyl morpholine oxide. So N-methyl morpholine oxide will be the, this is called the NMO. N-methyl morpholine oxide will be acting as a co-oxidant, which oxidizes osmium 6 to osmium 8 again. Okay. So this will be making the oxidizing agent again, regeneration of the oxidizing agent. For this is the responsible. So for that, this one is the C. Now in the next, this one is the TSOH, and the PHH is the benzene solvent and the heat. So finally you'll be getting the D. So now you have to say what is the D product will be obtained. Dekho, in this particular scenarios, if you solve these questions, this will be involving a lot of important reactions. सारे के सारे important reactions का एक ही जगह पे है ना. So try everyone this question and give the correct answer to me. No slide is clear, Vaishnavi. Please refresh your page. आपका पेज ना refresh करो. Take 5 minute time for solving this question and give the answer. sorry, actually this question is completed till here. Okay, ये question ना B में complete हो चुका है. So these are the two separate questions. Okay, these are the two separate questions. So first question will be till this one. I think for that only you are not able to understand. Now the second question is having the another part. Okay, so it is always better to remove it down everyone. तो अभी के लिए रिमूव करना ही सही रहेगा. Okay, देखो. So you have to ultimately say what is the answer of the B. Question B में क्या होगा, right? Answer B में क्या होगा? Now whenever you will be having the Z double bond, you are having the two possibilities, right? आपके पास ना दो possibilities है. Either you can do one thing. Either you can write down the product, you can write down the two groups into the same plane, SI-ME3 and the C3H7. You can take it in the same plane में रख सकते हो, right? And MCQ, if you see the metachloroperbenzoic acid, so this will be undergoing the oxidations. Now since we do not know which side is less hindered and which side is more hindered, so both of the groups are equally probable, right? So you can make the above the plane also epoxide, you can make the below the plane also. So that is dependent upon you, that is your discretions. That is one type. Or since both of the scenarios are the Z alkene, so you can represent this particular both of the groups are present towards you. Okay, so this this above the plane represents this SI-ME3 and this C3H7 is presenting towards you. Okay, so obviously away from you will be the hydrogens, away from you will be the hydrogens. Now you can show the epoxidations. Now you will be showing the epoxidation in the plane. So now it is your choice that in which particular thing you give the preference, right? आपके पास priority कौन सा है किसको दिखाना. Now here is a very important part that will be taking place. देखो, now अब बताओ, in this particular scenario one side is the C3H7, okay, and in one of the particular group, and one of the particular group, this one is not the Me2 cell, right? Just change everything. This one is also having the another structure. Please change it everyone. So we are taking the same reagent, C3H7. So in this particular scenario, the C3H7 minus will be the nucleophile. Okay. So अब बताओ which of this will be the purely SN2 reaction. So in the SN2 reactions क्या होता है? Backside attack takes place. In the SN2 reaction, the backside attack takes place in such a way that the nucleophile attacks from the less hindered side. So what do you think, everyone? One is the SI-ME3 group and one is the C3H7. So which of the side is the less sterically hindered side for this case? इस केस के लिए कौन सा साइड को less sterically hindered होगा बताओ? Which of the side in this particular scenario is the example for the less sterically hindered side? Exactly. So for this particular case, C3H7 is already there, right? Now if in this particular scenario both of the C3H7 is attacking, so there will be the steric index. So the nucleophile will be attacking to the particular group in such a way that it attacks from this type of group, this side, and this will be broken. So finally क्या होगा आपके पास? You will be forming the SI-ME3. SI-ME3 is in this side. Now hydrogen is this side. Now this one is the C3H7. hydrogen is this side, C3H7 is this side, and there is OH. Now we have to make sure that we are writing down the 2C3H7 in a particular zigzag conformation. Okay. Yes, B side में अटैक नहीं होगा इसलिए क्योंकि if that is attacking, then both of the groups will be having the C3H7. So they will be creating the steric hindrance. They will be creating the steric hindrance. So that is the reason. So if the C3H7 is happening, then बताओ SiMe3 का stereochemistry क्या होगा? So what will be the stereochemistry of the SiMe3? So this is normal V. So there is no necessity of changing this molecule, right? So SiMe3 will be remaining as it is. But whenever you are taking care of this one, तो अब बताओ what will be the stereo of the hydroxy? Hydroxy stereo क्या होगा? What will be the stereochemistry of the hydroxy? In that particular scenario, any side attack is possible. Me2Cl is an example for a weak, like less sterically hindered nucleophile. In that particular scenario, any side attack you can do. इधर से बेटा कर सकते, इधर से बेटा कर सकते. So ultimately, the hydroxy group will be remaining present into the below. So now आप बताओ. Now if you want to convert this molecule to the E-alkene, if you want to convert this molecule to the E-alkene, so you will be using the acidic medium or the basic medium. Which medium you will be using? कौन सा medium use करोगे? So in that particular scenario, you will be using acidic medium or the basic medium. So obviously, if you want to form this particular group, always remember acid में anti elimination होता है. Acid में anti elimination होता है. So SiMe3 and the hydroxyl group are already present into the anti. They are already present into the anti. Now if you form the acid, then there will be just directly double bond formation, right? So C3H7 and this one is having the C3H7. So are you understanding how we can convert this molecule to this molecule in this way? The geometry of this alkene is the E. So let's take the same examples and give the correct answer of this question. I am giving a new questions to you. So OAC, here is a CO2Me, here is a SiMe3. Now in the next step, osmium tetroxide, potassium tertiary butanol, acetone, water, and here you are using the N-methyl morpholine N oxide. So this one is an example of a co-oxidant. So which oxidizes osmium 6 to osmium 8. Osmium 6 को osmium 8 में convert करेगा, right? Co-oxidant, so that the presence of the oxidant is remaining the same. So this is product A. Now after this, we are treating this molecule the TSOH. You know, this is the para-tolerant sulfonic acid. This one is an example for a strong acid. Then PHH, benzene solvent, and heat. And finally, we are forming the B. So आपको बताना पड़ेगा what is the B will be formed. B क्या होगा actually? So should I give you the hint? I am give you the two options, right? मैं आपको दो options दे रहा हूँ. OH, OAC, So you tell me this one is A. C or tell me, okay? And option C is this one. These are the three options I have given, and you have to select one among this. So which one you'll select? Okay, so one is saying B. What about the others? Am I audible, everyone? Am I visible? Or my video has been stopped? Am I audible, everyone? Okay, I think I'm audible, but my video has been stopped, right? Okay, no problem. There is no videos required. Okay. So ultimately, for this particular scenarios, क्या होगा? What will be happening for this case scenario? देखो, osmium tetroxide will and osmium tetroxide in the medium of the water will undergo the dihydroxylation. But you know the dihydroxylation will be taking place into the less hindered site. Since all of the groups are present above, so above the plane is more hindered, right? So just write down, everyone, the above the plane is more hindered. Above the plane is more hindered. More hindered due to the presence of all groups. So the dihydroxylation takes place कहाँ पे? So that is the reason because of which the dihydroxylation reactions will be at below the plane. Below the plane में dihydroxylation reaction होगा, right? In the below the plane there will be the dihydroxylation reactions. So finally, for these molecules, the stereochemistry of the both of the hydroxy group will be actually below the plane. Here is also below the plane, here is also below the plane, and keeping the other groups remaining the same. OAC, and this one is the CO2Me, and this one is the SiMe3. Okay, in the next step, we have directly been using the H positive or the proton source as a solvent. So क्या होगा? In the first example, this will be getting protonated, this will be eliminated, and water will be attacking to the silicon. This will be forming the double bond. So ultimately, in this scenarios, क्या होगा? There will be the double bond formation over here. So here is a hydroxy group that takes place, and this one is OAC, and this group is the CO2. So finally, you will be obtaining this particular group. So we are doing the most important questions. Okay, done. Now let's do the next. In the next questions, the next question is having the structure like this: methyl, and here is a SO2 pH. Don't worry, I'll be giving you the shortcut of this question also. So after that, the first reagent that you are using is the butyl lithium. First reagent you are using the butyl lithium. The second reagent that you are using is having the group like this, CHO in this side, and this is the group, this is the A. In the next, you are treating the molecule with the Me, SO2Cl. 2 is the sodium amalgam, ethanol. This is forming the B. So now you have to tell me which one is the B, which one is the structure of the B. You will be getting, okay? B का structure क्या होगा? So I'm giving you one hint. This one is an example for the Julia olefination reactions. Julia olefination reaction. So since the name suggests, you are understanding that this one will be followed by the olefin formation. Olefin formation hoga, right? So how the olefin formations will be taking place, and what will be the mechanism, and what are the necessary conditions that you have to take care of. So you have to know each and every point. आपको सारे के सारे कुछ करना होगा, right? तो बताओ क्या, how these reactions will be taking place. Okay, चलो देखो. So if you know this particular question, then please tell me everyone. So you know that there will be the bond formation will be between, okay? There will be the bond formation takes place. Now my question is that the new bond formation will be taking place with the A carbon with the B carbon, or this one is a C carbon, or this one is a D carbon, or this one is a E carbon, or this one is a F carbon, or there is a G carbon. So the new bond formation takes place, or the double bond formation takes place in between the A carbon and the which carbon batao. So that is the question. If you know this, then you understand the Julia olefination reactions. Julia olefination reactions then आपको पता है. D carbon. Okay, very good. So the students who do not know the mechanism of this, so for that I am drawing the mechanism. In the first examples, क्या होगा, the Me here is the SO2 pH group is there. SO2 pH group is an example for the electron withdrawing group. So as all of you know, electron withdrawing group के presence में negative charge form होना आसान है. Now this negative charge will be getting, and let's take whole of the group as a R group. Okay, let's take whole of the group as a R group, so that we need not to have write down all of the part again and again. So now finally here is a R and here is a CHO. Here is a R and here is a CHO. So now this negative charge will be attacking to this carbonyl compound. This will be forming the O minus. So ultimately for this molecule, basically the group will be taking places like this. So here is a SO2pH, and there is a new bond takes place between the R and here is OH. Sorry, here the OH will not be taking place right now. Here it will be forming the O minus, है ना? अभी तो ये O minus ही बनेगा. So now in the next step क्या होगा? In the next step you are treating this molecule with the MeSO2Cl. MeSO2Cl. So now the OH is not an example for a good living group. So ultimately क्या बनेगा? So this one will be forming the good living group. OMS बनेगा. So this one is the SO2pH. There is a new bond formation takes place. Here is the OMS. Now OMS is an example for a good living group. So for the molecule ultimately क्या हो रहा है? In this particular scenarios, whenever the sodium amalgam is there, sodium amalgam there दिया रहेगा. In that particular scenario, the molecule that will be taking place will be like this. Then there is a negative charge generation takes place over here. Okay, and here is the OMS, here is R. In the next step, this will be forming double bond and the OMS group will be eliminated. So finally the group will be attached with this double bond and here is a R. So ultimately this carbon is basically the B carbon, as you have said. You are correct. Okay, this carbon is the B carbon. Don't forget to give the other reactions. Other carbon के साथ जोड़ मत देना, है ना? Because that is the other carbon. So is it clear? Now in the sum of the processes, so ultimately here क्या form होता है? So what is the necessary thing that you have to remember? You have to remember the things that both of the groups will be having the trans geometry, or in these Julia olefination reactions the E alkene will be forming. So that is the very important characteristics of these important reactions. E alkene formation is the important characteristics of the Julia olefination reactions. Exam में बहुत पहली बार आ चुका था, right? In the examination it has already came. So great. E alkene, yes. So now in the next examples, let's suppose you are having an intermediate like this. अगर मान लो आपके पास एक intermediate है, which one is containing the sulfur, which one is containing the nitrogen, and this one is having the 5-membered ring, and this other group is the having the SO2, H double bond oxygen, and this R group is present above the plane, and this R group is present below the plane, and this is O minus. So what will be the next step? In the next step, the negative charge will be attacking to this electrophilic position in such a way that the negative charge will be forming to the nitrogen, right? Because nitrogen will be forming the negative charge, and there will be the new bond formation takes place. There will be the new bond formation takes place in between the this and this group. This is the new bond. This is the newly formed bond. Sulfur double bond oxygen, double bond oxygen. Now here are the stereochemistry of that. So they will be presenting, they will be rotated in such a way that they are presenting into the opposite directions. Let's suppose one is R1, one is R2. Okay, great. Now in the next step क्या होगा? Now in the next step, nitrogen lone pair of negative charge will be forming the double bond. Then this will be forming the SO2 group. Then this will be eliminated as a molecule. So finally आपके पास क्या form होगा? So finally in this particular scenario, you will be getting the group as the SO2, sulfur dioxide elimination. So elimination of the sulfur dioxide takes place. So what will be the charge of the sulfur? Sulfur के वो charge क्या रहेगा? So there will be neutral charge will be remaining. Okay, there will be the neutral charge will be remaining. And in this scenario, sulfur double bond of nitrogen, and this will be the final product of the reaction. So this will be the final product, and here is the formation of the E alkane takes place. यहाँ पे क्या बनेगा? E alkane formation takes place. Is it clear, everyone? Okay, very good. Sure. So hello everyone, I welcome you all to the India's largest learning platform, that is Unacademy. Unacademy is the India's largest learning platform and is a great platform for your upcoming CSIR-NET as well as the GATE examinations. Myself, All India Rank 2 in JRF, All India Rank 36 in the GATE examinations, will be teaching you the all complete organic chemistry into the Unacademy Plus. So if you have not seen my classes into the Unacademy Plus, then just take the Unacademy Plus subscription just right now. Use my code CREEPLIVE for getting the 10% of discount. Don't worry, you are having a very good offer. So today is the 28th and this offer is valid till today. So the last date is the today. This is a limited period offer, and if you take the Unacademy Plus subscription today, you'll be getting the 20% discount. Okay. So, and you know 20% discount is one of the highest discount ever in the Unacademy. So, and this offer is not, this offer ना बहुत बाद ही आता है ना. So इसलिए if you take the Unacademy Plus subscription, so it is a great thing. Achieve your CSIR UGC NET goal with a 20% off on all of your Plus subscriptions. Okay. So for that, use the code CREEPLIVE, KRIP CREEPLIVE. Since you are watching my into this YouTube live, so use the code CREEPLIVE code for getting the 20% discount. You'll be getting the opportunity for the 20% discount on your Unacademy Plus subscription. Okay. So there is a new feature has been introduced to Unacademy in which your all of your doubts will be cleared. You'll be not having a single doubt present over your brain, because all of the doubts will be cleared by the doubt clearing faculty. Okay. So you have to raise a query or the doubt, and you'll be sending the doubt to the doubt clearing educator, and the doubt clearing educator will be giving you the solutions in this regard. If the solution is unique, then the subscribed learners, that means the students who has taken the Plus subscription, okay, they will be getting the opportunity for getting a detailed video solutions. The solutions are available into the CSIR UGC NET. Now I have already taught the special classes of the Claydon. Claydon I have already completed. Claydon I have already completed the 135 hours of class. I have already completed the 135 hours of classes, and that is a full Claydon. So full Claydon is for absolutely free. So for that, you have to just download the Unacademy Learning app, and after that watch my free classes over there. So this is a really great thing for you. A lot of students are watching these free classes and get the benefit. So why not you? Yes, should do. In this example, this will always be forming the E-enolate. Yes, always be forming the in these reactions of the Joule-olefinish reactions, the molecules will orient in such a way that in that particular scenario the E-alkene will be forming. So आपके पास E-alkene ही बनेगा. Okay. Great. So these are the procedure, these are the steps in which you will be getting the opportunity for using the group ask it out, right? So here you will be getting the opportunity for asking a doubt directly. So click and doubt and go to the doubt and solutions feature on your home screen. Then click ask it out and upload your doubt image. Crop the image and highlight the questions. Choose the subject that the question falls under and just click on that. Okay. Then you'll be getting this particular group directly. Okay. So do not forget about this offer. This offer is valid till today only. Today is the 20th of April, and today is the last date of this offer. So last date of this offer. So last date of the offer is the today. Okay. Try to take the Unacademy Plus subscription today as soon as possible. These are the pricing of Unacademy Plus. So if you take the 12-month course, you have to pay 15,950 rupees. This is the normal pricing, but in today if you take the Plus subscription, you'll be getting into the 12,760 rupees. So you'll be getting the 20% discount. So you'll be saving 3,190 rupees. Okay. In the normal days you'll be getting only the 10% discount, but in today you'll be getting the 20% discount. If you take the Iconic subscription, you'll be getting the extra study material, and one of the educator will be actually taking care of all of your ऑल ऑफ योर प्रोग्रेस ऑफ द स्टडीज में कितना प्रोग्रेस कर रहे हो उसके बारे में टीचर ख्याल रखेंगे. ओके, and he'll be guiding you in throughout your journey. Use code Krip Live code for getting the 20% discount. These are the normal pricing. You'll be getting the 10%, 20% discount on your class as well as the iconic subscription. So if you have not visited my previous classes, then do visit. In the previous classes, I have done all of these questions. So in which you will be getting a clear-cut idea about the organic chemistry. Exam में किस तरीके से questions आता है, and you will be also getting the time to practice, right? Okay, so try to take these questions and keep on practicing. Then you will understand each and every point. So now let's give you some of the homework to you so that it will be very easy for you for understanding, right? Now to the next day we'll be starting the Corey-Winter elimination reactions. As you know, Corey-Winter elimination is a very important name reaction. Okay, so let me give you the some of the homework, and I will be seeing all of yours. Okay, homework. So I'll be taking the homework. So first example. So if you take this 6-membered ring, and this one is NMA2, and here is a phenyl group. Okay, and after that you are treating this molecule with the MCPB, metachloropyrbenzoic acid, that is getting A. After that you are doing the heat, that you are getting the B. Then the second examples. NMA2, and the stereochemistry of the phenyl group is also above the plane. Then also if you are treating in this molecule with the MCPB, this is forming the A. Then the heat, this is B. So you have to say which of the product B will be forming, right? B कौन सा बनेगा? Now into the next examples, if I talk about third examples. N means acyclic. Okay, N means normal. Normal means acyclic. It will not be cyclic. N represents no cyclic. Okay, NCHO, is from aldehyde group is present. So plus this is traded with the CO2Me, and here is selenium phenyl group. And now we are taking this molecule with the PiCl4, isopropylamine CH2Cl2. This is forming A. Now in the next step, acetyl chloride, pyridine and the CH2Cl. This is giving the B. So you have to say which of the product is B will be forming. Okay, so all of you write down this. So these are the 3 questions of your homework. Do not forget to like the video if you like the video, and do not forget to subscribe this great channel. In this channel you will be getting the opportunity for learning from the India's top educators. There are lots of free classes are there in which you can able to understand the organic chemistry, physical chemistry and organic chemistry from the India's best educators in this particular YouTube channel. Subscribe this YouTube channel and like the videos and share among your friends. These are the 3 questions which are taken as a homework. I'll be seeing all of yours. I'll be seeing how many of you have done this correctly. Okay. So thank you so much everyone for attending. I hope all of you will be working very hard for your upcoming CSIR-NET examinations. Work very hard till you get the JRF. Let's crack CSIR UGC NET GATE examination with a brilliant rank. Bye everyone. And